CSIS 2470 is filmed before a live studio audience.
Hey everybody, welcome to class. Today we're going to be talking about regular expression, and the footage you're about to watch is actually about 5 years old. But I kept it because it's a really good explanation of what regular expression is and how it works. And this was actually filmed live in a classroom, and so there will be some audience, there'll be some student interaction and some questions being answered on the video. And then the whole video is language independent. PHP, JavaScript, Java, it doesn't matter what language. Obviously for this course, it's for the JavaScript. But what we're going to learn in the next half hour or so is just what is regular expression and how it actually works. And we're going to be using a tool called regex101.com or something like that. You'll see it in the video. But what it allows you to do is put in a bunch of text and then test out the regular expression and see if it works. So the next half an hour will be going over how regular expression works, what it is, and at the very end, there'll be some brand new footage of using it in JavaScript and how you would actually use regular expression in your code. So buckle up, get ready for a fun little 30-minute journey. I'll see you on the other side. This is a website where you can put in some text and then you can use regular expression to search through it. And the first thing we're going to look at is where you can search for and find just an individual character, okay? So if you use the dot, that means literally find anything. That's the wild card. So part of what you're probably wondering is, what is regular expression? What's it for? What's its purpose? This was invented in 1951. This is old. It was in Unix-based systems. And I mean, 1951, that's 6 years after World War I ended, or World War II ended, I meant. All right, I mean, that's a long time ago. Computers were barely a thing, okay? So this has been around, and there's a link in there if you want to check out the history of it. But the idea is it's to look for patterns. Search through a string of text or a document of text and find patterns. And right now you can see that putting a dot there, it highlighted every individual letter. That's why the coloring is alternating with blue and light blue, because it's found each individual one of those. At the very top of the page there, it found H, and then it found also A, it also found P, it also found the other P, right? All right, if I want to find just only a single digit, \D, and the cheat sheet has all these things that I'm telling you that you can download. \D, so if you look, it searched through this document, and it found all the single digits. Those phone numbers, and then Butthead's email address has 42 in it. So it found the 4 and the 2, all right? If I wanted to find, say, only cases where there's exactly 2 digits in a row, another /D again. So now this is only finding where I have exactly 2 digits. That's why you'll notice here that this 80, for example, is not alternating colors. It's found both. It found a /D and a /D, okay? Or how about 3 digits, okay? Or 4 digits. Now it's only finding those. So that whole string that's in the top part where it says regular expression up there, that whole thing it's looking for that exact pattern. What is that pattern? Digits. Single, 4, exactly 4 individual digits, right? Now you'll find this is pretty common that whenever there's a /something, there's also the uppercase version of it, which is the opposite of the lowercase. So in other words, that is anything that's not a digit. That's \D is anything that's not a digit, okay? And as you can see, it's selected everything on that page except for digits. And again, this is one character at a time. It's selecting every individual character, okay? This is all character-based. It's not strings, it's characters, all right? So the second one, and again, I'll probably say this 5 more times, but you can print this out right from the lecture notes. It's a cheat sheet that has a list of all these and a little explanation, so it's pretty straightforward to follow. So /W, too many slashes, finds word characters. What do you suppose non-word characters would be? Capital W, /W, right? So it finds all the non-word characters, which is spaces, asterisks, periods, numbers, dashes, hyphens, all that stuff. Anything that's not a word character, right? So if I wanted to find a word that was exactly 4 letters long, or at least 4 letters in a row, if I want to find a whole word, we'll talk about that in a minute. But this is a block, this is looking for a block of 4 letters in a row, which is why the word up is not selected, but the CURR is on the second line there, okay? All right, let's take a look at the next one. White space, or just a space, right? A lowercase s, again, all these are prefaced with a slash, right? A slash, lowercase s, and it's a \. And this will find every single instance of a single space. Now, what do you suppose not white space is? Capital S. Well, yeah, it's everything else, but it's the capital S, exactly right. So every single individual letter, every single number, dash, symbol, all of that is not white space, okay? So those are all single characters, all right? The next thing we're gonna look at is what is called sets, where you can do sets of parameters, all right? So take, for example, let's go with the sets go inside of square brackets. Okay, so those are square brackets up there. I know the highlighting is a little wonky, but that's a set of square brackets. Inside the square brackets, let's say I want to look for the letter A or the letter S. This scenario is not looking for as, right? Can you see that? Is it big enough? It's not looking for as, it's looking for an A or an S, or a D or an F. Not an ASDF, but one of those. It's looking for one of those, okay? So inside this set, I'm saying, here's a set of 4 letters. Find any one of those individually. There's no commas to separate, you just stick them all together. And so you'll notice, like in the Happy Happy Joy Joy there, the A is highlighted. In Dave Mustaine, you got the A and the S, and then in Bruce Dickinson, you got the S, Hetfield, you got the D, right? It's only looking for those individual letters. So this can be useful in finding phone numbers, all right? And eventually we're gonna learn how to stick this in our code and validate to say, hey, is this actually a legitimate phone number pattern, right? What's a phone number pattern look like? And let's just stick with, the US and not having to deal with country codes for a minute. What's a pattern look like for phone number? 3 digits, some separator, right? Sometimes it's a space, could be a dash, could be a period, could be an underline or an underscore, but typically it's a dot or a dash, right? But some separator, then 3 more digits, and then some separator, and then 4 more digits, right? All right, well, let's look at that. So let me find the phone numbers actually in the text field right here. We're gonna see if we can find those, okay? So 3 digits, and then I'm gonna do my square braces where, let's start with just a dash, right? Then a dash, right? And it found a dash, no problem. 3 more, dash, 4 more. So that will find, and notice the whole phone number is highlighted because that whole phone number matches that pattern that I have up there, okay? But it didn't catch the underscore, it didn't catch the dot, right? So we're gonna do a set. Instead of a dash, we're gonna do a dash inside of the square brackets and also a dot as in a period. And then we're gonna come over here, dash, dot. And now it's saying, look for, in fact, I'm gonna copy this real quick, if it'll let me. I don't know if it'll let me. Let's see if it copied it or not. It's a little easier to see it in a text. Yeah, okay, it's a little easier to see it there. So this is, give me any string that matches the following pattern. 3 single digits in a row, followed by either a dash or a dot, followed by 3 single digits in a row, followed by either a dash or a dot, followed by 4 single digits in a row. Now, the question was, can you look for white space in the square brackets? So let's update this here and go with 801 555 1212. Okay, 1212, right? All right, so now we're doing it with spaces, okay? So we would look for, now you could just do, let's see what happens if you put a space, okay? Let's try that first. Okay, we're just putting a space there as a character. So now it's gonna, theoretically, we'll see, theoretically, a dash, dot, or a space, one of those 3, okay? Let's paste it here, and there you go. It's a character, right? So it found it. Now, you could, as you pointed out, look for white space, and it also finds it, because that is white space, right? So either one of those is fine. I recommend going the white space route because a single space, you can't see it, right? When you type it, you can't really see it, right? All right, so we'll leave the space in there, might as well. Then we're gonna also look for an asterisk, and we're gonna look for underscores as well. Now already look at this. This is like messy. What is this, right? But this will find every phone number that I have listed here at the moment, right there, okay? Yeah.
If you had the parentheses, would you put a set in the front of the number as well?
Yeah,
or
so
just look for a parenthesis and then a set in the middle?
Yeah, so the question is, what if you have parentheses? Like the old way that we used to see phone numbers all the time, we don't see this very much anymore, but it would look like this. 801, and maybe a space, maybe not. Let's go with the space, 999, 1111. You'd see that a lot, or you'd see a variation of that here without the space, right? The way to solve that is something we haven't covered just yet. We're going to get to in about 5 or 10 minutes, so I'm going to leave that there, and we'll look at how to deal with that in just a minute. But you're on the right track, right? So we'll look at that in a second. But anything that doesn't have It's just got the pattern of 3 digits, some separator, 3 digits, some separator, and then 4 digits. We're going to find it with this, okay? So now, here's another thing you can use the brackets for, okay? I showed you already that I can search for a dash or a dot or a underscore or whatever, and it'll find all of those. Maybe we'll throw in an @ symbol in there, @ symbol, okay? What you can also do is at the very beginning of the brackets, put a caret, the thing above the 6 that you use for exponents, right? And what this means is find anything that's not in the square brackets, right? So now it's finding everything that's not a dot or a line or an underscore or an @ symbol. And as you can see, it's not highlighting the @ symbol there. It's not highlighting the dashes there. It's not highlighting the periods there or any of the white spaces or anything like that, okay? Well, the white spaces would be, but because they're not in the brackets, okay? Make sense? What if I wanted to find an actual caret, right? How would I do that? Yeah, so let's back up here. I think I have a caret in here somewhere. Yes, right here in this math equation. Metallica times Maiden times Megadeth equals M to the 3rd power, which is metal to the 3rd power. Should be that, metal, right? So raise to the 3rd. So I want to find that. Well, I could start off just like this, okay? And it doesn't seem to do anything, right? Because it has a special meaning. Caret has a special meaning. What if I put it in the brackets? Well, it's saying, don't find the stuff that's in the brackets. Well, there's nothing in the brackets, so it's just kind of sitting there, right? What if I escaped it? There we go, okay? On this handout, there's a list of things you'll have to escape. So we're escaping that caret, and it's going to find the caret, right? So what if I wanted to find everything that's not a caret? What would you do? Yeah, caret, escape, caret, right? So you can see how this stuff can build and quickly get crazy out of hand, right? Okay, and wait till we're going to look at some that are nuts. Okay, we're going to build a few too. There's one other thing we're going to look at here, and that's groups. Okay, groups, you put in parentheses, and for example, let's say I put happy in parentheses. That will just find any instance of happy. Now, you also know I can get happy like that without the parentheses. Okay, putting the parentheses on it helps us to be able to do some useful replacing things, right? So the parentheses are going to come in handy later, so we'll come back to those. But right now, if I wanted to find happy, I can find it like that, okay? It is case sensitive, yeah. So happy is not the same thing as capital happy, yeah. All right, so we looked at individual characters where we just did /D, /W, /S, right? Digits, non-digits, word characters, non-word characters, and white space and non-white space. Also note real quick, word characters will pick up numbers too. It's words and numbers, okay? Because you could have a number in a word, in a sentence, basically. That's the idea, okay? Anything that you could use in a sentence that's not the punctuation, you can have that there. Now, you could argue, well, I might have a sentence with an asterisk, right? But the definition is characters like numbers and letters, basically. That's it, okay, for /W. Okay, individual characters, sets, we looked at that. Let's take a look at this other idea. They're called anchors. Anchors are a little weird. The first one is the /B, lowercase b, okay? And what the /B is, it's what's called a boundary, a word boundary, okay? A word boundary, what do you suppose a word boundary is?
The space around a word?
Yeah, anything that you visually looking at it would know, oh, this is clearly separating it from, it's a word, right? So it's the beginning of a sentence, that's the end of a sentence is the end of a boundary, a space in between it, something like that. Those are word boundaries. So if I wanted to find the scenario where happy exists, capital H, happy, but I want to find it only in the situation where it's a separate word. It's not part of another word. So in other words, happy. Notice it did not, on line 3 there, it did not select the second happy because there's no word boundary there, right? It selected the first happy because what I did, /B says, find a word boundary. It found one, start of a line. And then it said, immediately after that, look for capital HAPPY, okay? Notice also that the first line, it selected both happies because it found a word boundary, new beginning of the line, then it found happy. Then there's a comma, then it found another word boundary, which is the space there before the word happy. Dig it?
Can you dig it?
All right, there's also a capital B, which would be not a word boundary, which is going to find the other happy there, because that's a happy that doesn't have a word boundary at the beginning of it, okay? And again, remember, this is individual things one at a time. It's literally looking for a situation that's not a word boundary, which if I back up, that's all over the place, right? There's all kinds of places that are not word boundaries. Find a word boundary, look immediately next to it for a capital H, and then immediately after that H, look for an A, then look for a P, then look for a P, then look for a Y, and you'll find that, okay? That's one situation, but you can also say, like, let's look for joy, which we found. Then following joy, I want to find a word boundary. So now this is saying, give me every scenario that has a capital J, followed immediately by an O, followed immediately by a Y, followed immediately by some sort of word boundary. As you can see on line 1, the word boundary is that comma there, and the word boundary on the last joy there is the end of the sentence. Same with the joy on the third line. Okay, good? Yes, so if I did, let's go back to the happy here. So I had this, and I'll find the middle happy, but if I have a word boundary at the beginning, then it will not find that happy, because the thing we have in our regular expression says, find a word boundary, followed by immediately a capital H, A, P, P, Y, followed immediately by a word boundary. And there's no scenario where that exists. Well, there is, those 3 that are highlighted, but the scenario that says happy, that does not exist, right? That condition doesn't exist. Okay? Now, there's also another sort of anchor here, it's the caret again, okay? The caret means something different when it's outside of the brackets. This is why regular expression is hard, okay? Caret outside the brackets means it's the beginning of a line, and you can see all the little pink along the side there. It's the beginning of a string, I should say. Okay, it's the beginning of a string. So if I start typing this, then it's finding the first line that says happy, comma, happy, and it's finding the third line that says happy, happy. Because what did I look for? I looked for a scenario where this is the beginning of the string, followed by a capital H, followed by an A, by a P, by a P, and by a Y. Dig it?
Can you dig it?
You can also do end of line, which is the $sign, okay? So I can say happy, and then if I put a $sign, there is no condition where that's met. There's no scenario where it has a capital H followed by the rest of the word happy, followed immediately by the end of a string. Now there's places where there's a word boundary, but not the end of a string, okay? If I were to put joy there, we would have that scenario, right? Joy is the end of those 2 strings. Or simply this, just an N in a string. That gives me Maiden and Dickinson and Burton down there, okay? We're going to take a quick little pause here and tangent for just a minute before we cover the next subject. You look in something like Notepad++, and I want to do a search. Notice here in my search, I can actually use regular expression right here. I can use regular expression, and whatever I put there, it'll search for that pattern. So this is everywhere. Sublime Text has this feature. In fact, Sublime Text has built into it like a real-time thing like this page here, where I can open up a little command thing in Sublime Text and search real-time for patterns, right? This is used on the command line in Linux. You can do this kind of stuff. You can write Linux shell scripts. It's used everywhere. Pretty much every programming language will have a function that can take in as a parameter a regular expression pattern and compare it to a string, and then tell you if it matched, or it can say to replace things in there. There's all kinds of cool stuff. We're going to deal with that in a minute. But I just want to point that out. This regular expression is not just here. If you're familiar with, like if you're more of a server person, I'm not a huge server guy, but there's a file called the htaccess file on servers. You can use regular expression there for redirecting your URLs and all kinds of stuff, okay? All right, so next thing, we're going to look at quantifiers, right? What's a quantifier do? Like just in English terms, what's it sound like it does? Yeah, it counts. It gives a specified number of things. So, for example, one of the quantifiers is you can put a number in curly braces, 3. What that means is, let's take a look here. I want to find a digit, right? So let's go down here. It's finding a bunch of single digits, but I want to find exactly 3 of them in a row. So that is the same thing, /D. This is the same thing as that, okay? So I could replace this right here, replace that, and replace that and put a 4 there. And this is the same pattern. This will find our phone numbers, just like it did before. Oh, did I? What did I copy? Extra? Oh, yep, nice. Sorry about that. Well, I copied too much. I deleted too much, so I missed the dash and the period there. All right. Oh, yep. Yeah, I went too far. Okay, there we go. Thanks. I wasn't looking. There we go. So that will find our phone numbers there, okay? So that's one little shortcut you can do. You can also do situations, let's go over to here, where I can say something like 4, 9, which will mean anywhere from 4 to 9 of these, okay? So you could do this. This would not be ideal, but you could do this. I'll tell you why this is a bad idea. a second, but you could do this. This will actually work, okay? It'll find the numbers because it's found anywhere from 3 to 4 digits, followed by those things in the brackets, followed by anywhere from 3 to 4 digits, followed by things in the brackets, followed by 4 digits. What's wrong with that though? Yeah, I could have a phone number that's 8019 dash something and it would still show up here, which is invalid, right? So I could have 99999 dash 99999 dash 99999, and that will actually show up as a valid phone number because I said it could be 3, up to 3 or 4, right? So, but I just want to show you how that worked. There are scenarios where that's useful. Okay, so that one quantifier. Now, let's take a look here at the other ones. There's a couple more, and let me just put them on this page here. There's the asterisk, the plus, and the question mark, okay? The asterisk means either 0 or more. That's what we're used to the asterisk meaning in programming languages, right? It's the wild card. It means 0 or more of them, right? So what's the difference between that and a dot? Remember I told you earlier the dot means everything? Technically the dot means anything, not everything. It means anything, and it means any individual thing, right? So, for example, I could, if I wanted to, do this, dot. What does that mean? 3 digits followed by literally anything, one thing, but just one of them, but literally anything, followed by 3 digits, followed by literally anything. So if it's a space, a dash, a hyphen, a period, or whatever, it'll find it. Now, if it's another number, it'll also find that, right? So this isn't the best solution either, but that's what that would mean, okay? Feeling okay about that? All right, so let's go back to the way that was. Okay, the dot means just find every instance of any given character. The asterisk is counting, okay? It's counting. So in other words, I'm saying, let's go down here. I think I have a scenario where I have some, these names here, okay? So I want to find all these guys here, Mr. Crowley, Mr. Brownstone, Mr. E, Miss Jackson, if you're nasty, Mrs. Robinson. These are all song titles, guys. Mr. Roboto, Mr. Jones, and me. So they all start with a capital M, right? Easy. Put a capital M up there. Some of them start with an R or have an R next, some of them have an S. We'll deal with that in a minute, all right? Let's just look at the misters first because they're easy. So MR, easy. But now look what's up. We have a period, right? But sometimes we don't have a period. Like Mr. Brownstone doesn't have a period. Well, first of all, I want to find the actual period, not just quote anything, right? I want to find a period. So we can escape it, get a period, but now I missed Mr. Brownstone, right? Well, I want to say for the periods, I can have 0 or one of them. There's either 0 periods or 1 period. The quantifier for that is the question mark. So now it's saying, give me a capital M, give me an R, then give me a period, like an actual period, not period meaning everything, but an actual period, and that actual period, I can have 0 or one of them. That's the question mark there, okay? So that is this right here. So we're gonna deal with the misses and the Ms in a minute, okay? But now what's next? I'm looking for what? A white space, right? So a space, just one. Then I'm looking for a capital letter. Well, remember the brackets where I had the brackets and I could put, capital A, B, C, D. I could put, and it'll only find one of those? Well, obviously, we can just do A through Z. And so we don't have to type that out. So A through Z. That means any capital letter A through Z, okay? What's immediately following that? It could be an uppercase letter too, theoretically, right? A name like O'Reilly or something, and they'd left off the apostrophe. We'll deal with the apostrophe another time, but something like that. But there are names where the first 2 letters are capitalized. So what I want is just any word character. Maybe you have a number in your name, I don't know. Maybe you're a robot, right? So /W, okay? Well, I meant lowercase w. But now look at what happened there. We just lost Mr. E, right? So what do we want to say? Well, I want to say after the capital letter, there can be 0 word characters, or infinite number of them. That's the asterisk. That's what the asterisk is, 0 or more. Now, I'll put this in the text editor again so we can look at it a little more closely. So here we're saying, give me an M, a capital M, an R, followed by a period, and that period, that thing that I just wrote, I can have 0 or one of them, followed by a space, followed by a capital letter, followed by any word character, and that word character that I just wrote, there can be 0 or many of them. That's what we've got so far. All right, that actually covers all the misters. What about the misses? Okay, Well, there's an or operator, right? So you can do this. I can say, give me an M or, give me an M, R, or an S, right? But the problem is it's not going to quite work unless we put this in a group marker, which is the parenthesis here, like so. So now notice Miss Jackson has been chosen. So the parenthesis there says, give me an R or an S or an RS, right? So let's look at that. Here's the final version here, okay? Give me a capital M, then give me one of these three patterns here, either an R or an S or an RS. Followed, whatever that is, by either 0 or 1 period, followed by a space, followed by exactly one capital letter, followed by either 0 or many word characters. And that will pick up all the Mr. and Mrs. and so forth, okay? Now, there are other scenarios you could probably contrive that we might have missed a person there, like you were talking about the hyphen. And actually, I think, let's just type Mr. O'Reilly there. Let's see. Yeah, so he is missing his apostrophe. So we could put in there, let's just see if we can capture that. Right before the word character, we could put just we could put the apostrophe if we wanted to. That'd be a tricky one. Let me think about that. Because it's not a word character. Yeah, we'd have to explicitly put that. And we can have 0 or 1 of them, right? So that would capture it. You could do that. Okay. So that would mean we'd have to think through, are there other things like hyphenated last names, right? We'd have to have that kind of thing. And so, for example, what if the apostrophe was like there? I know that's weird, but what if it were there? Well, we got another problem, right? In fact, even if this were lowercase, that's still an issue. So how would we solve that? Well, you can say this. You could put another one of these cats. Let's put this on here. You could put another one of these guys right after the capital letter. Let's say that it has to be a capital letter. That's one of our rules, okay? Followed by 0 or many characters. Followed by an apostrophe, 0 or 1 of them, followed by 0 or many characters. So that will give the scenario where it's immediately followed by the R, which is our W right here where my cursor is blinking, then the apostrophe, and then the rest of them. That should catch everything, and it does. The question was, can I put a hyphen right there, and that would catch hyphenated. That should catch them. So let's go with Ms. Love Hewitt. Is that, how do you say her name? Spell it? Close enough, but it picked it up, right? Jennifer Love Hewitt, right? All right, so anyway, it worked, right? It worked, that was the point. We're just trying to make these little sections work here. Okay, so this stuff is tricky though, and you guys are asking some good questions. So those are the quantifiers, all right? So let's take a look at these email addresses down here. I want to pull out of it just that part. I don't want to pull out the HTTPS, and there's places where that's valid. If you're using code to grab something out of a URL and you're getting a whole URL, and then you want to modify it so that you can just display the URL name and the dot whatever instead of having to display the HTTPS. There's cases for that. You might want to do that. All right, so let's look up here. What's the first thing I'm going to type if I want to start looking for those? Yeah, HTTP. Whoops, P. Now what?
Bracket, semicolon.
Not quite. Yeah, so an S and not an asterisk because that would allow you to have many, right? Question mark, which is 0 or 1. So we put, that means I can have an HTTP, I have to have that. Then as far as the S goes, I can have 0 or 1, followed immediately by a colon, followed by // Now notice the slashes didn't appear.
You have to escape them.
Yeah, you have to escape them and get that. So you see how it starts to get out of control here, right? Okay, followed by www or not, right? So we're gonna put that in parentheses for reasons that'll become clear in a minute. But a www, there's going to be either 0 or 1 of those. Dig it?
Can you dig it?
And actually, the dot would come along with for the ride with the W's, right? Okay, so www dot. Followed by word characters, any number of them. And it should it be 0 or more? Should I use the asterisk there? Because that would be 0 or more. I need 1 or more, right? Because you can't have www.com, but there has to be something in there. So there has to be 1 or more, right? You could have, maybe there's some website called, b.com. That probably is a thing, right? So the 1 or more is the plus, okay? So I need 1 or more word characters, followed by a literal dot, so I'm going to escape it, followed by word character. What's the minimum for an extension? You'd have to look it up to see what the rules are for a URL, but we're just going to assume that it's at least 2. Oh, that's a good idea. Yeah, so escape W, that's at least 2. And then, so that's 1. And then the second one, it's 1 or more of those. Good solution. Very good. See that? Okay, that gets it. Now, here's the whole reason we care about all this. Okay, we want to be able to search and replace. Step 1, we just spent an hour or whatever talking about searching. Okay, now let's figure out how to replace. Well, we're going to use a function to do that, but for now, there's actually a little tool right here on this page called substitution here, where you can put what you want to replace right here, all right? So these parentheses, actually, the way they work, every group of parentheses in a regular expression is actually assigned a variable. So this group of parentheses, that variable right there, its name is string 1, or $1. That's its name. If this had parentheses around it, which this would cover, this is the actual URL name, that variable is called string 2. And when I say string, in the 80s when I first learned to program, the $, you called it string. That was what its name was. That was the name of the $. It was called string. Okay, so don't be thrown off by that. Followed by, actually we want to put the dot from the .com or whatever in parentheses. So that would be called variable number 3. They just go in order. First parentheses 1, seconds 2, and so forth. Why do we want to do that? Well, check this out. So we're searching for that. Now down here in my replace, I want to, let's scroll down here. Actually, let's clean this up by getting rid of all this crap here. All right, so what I'm gonna do here is just only have the URL so we don't have to scroll, okay? So now that's all we're looking at. So here's our search pattern here, and we lost something. It's not finding everything now. What did we miss? Oh, that period there. Put the parenthesis in the wrong spot. See that? That parenthesis should go there, and that. There we go. So it's finding everything, right? The different colors now are representing the different groups. So I want to replace that whole string with just whatever variable 1 is. Variable 1 is the www if it exists. Or I want to replace it with whatever variable 2 is, which will be the name of the URL, because that's what I put in the second set of parentheses. Well, I want to replace that whole thing with the second and third set of parentheses. Whoops, I don't know what happened there. So now I'm replacing this pattern with just this portion of the pattern, right to there. Let me do that in a text editor. I'm replacing, when I say this, I'm saying replace this entire pattern, anything that matches that, with just that part of it, right? So find all legitimate URLs and replace them with this. Okay, let's put this into action now. So we got a blank JavaScript file here that we're going to use in just a minute, but let's go back to the regex 101 site and imagine that we are only going to allow this form of a phone number, that, right? So we won't allow this form or anything else, only that first one. So let's just think about what that looks like. We first have to start with a parenthesis, right? So we can do a parenthesis, but the problem is a parenthesis is part of the grouping thing, right? So it's expecting that you're about to make a group. So we have to escape the parenthesis, right? So let's start by escaping the parenthesis. And then we're looking for digits, so /d, and we want exactly 3 in a row, followed by a slash to escape the closing parenthesis, and then the closing parenthesis. That's the first part, and you can see that it did pick up the pattern recognition there. Now we're going to follow that by immediately 3 digits, exactly 3 digits, followed by one and only one thing, which is a hyphen, followed by exactly 4 digits. So you can see that it's picking up the pattern of the first phone number. So let's say that the user entered one of those numbers there. If they entered the first one, our pattern recognition says, yep, you're good, you passed the test. If they enter the second one, then it says, no, you failed the test. We're going to see how to do that in the code in JavaScript right now. So let's just start with something simple. We'll say let user input, rather than building a form and everything to process it, we're just going to hard code it. So let user input equal 999, 999, 999, and we'll leave it there. All right. And then we'll say pattern. So this is a pattern we're going to compare it to. Let pattern equal, now here's where it gets weird, okay? In order to use regular expression in JavaScript, you don't actually put it in quotation marks. You put it in between what looks like you're making a comment, right? But you go in between there. So in between there is where you put the pattern. So I'm just going to copy it right out of here. Like we got it right here already. Might as well just copy it. And it goes right there. Okay, so this is the regular expression. This forward slash and forward slash is sort of like putting quotes around it, right? And different languages have a different way to handle it. This is how you do it in JavaScript. Then the next thing you do is you will say pattern dot test. So you're going to test that pattern on some value. What value? Well, in this case, we're going to do user input, right? And so let's just console that out. We'll just do console.log right here. And now when we go to the page and refresh it, you'll see that it is true because the pattern, when we tested it against this number, there was a match. But we're not quite done yet.
But I'm not done yet.
What if the user entered that? I just added an extra 9 at the end there. Believe it or not, that is a pattern match. When I refresh it, it's still true. Because this pattern is found within this string. In fact, I could put a G right there, refresh it, and it's still true because this pattern is still found within the string right there. So how do we fix that? Well, if you remember, we have the start of a line and the end of a line, right? So right here, before we do our parenthesis, we do a caret. That's the starting of the line. And then at the end here, we do an end of the line, which is the $sign. So now, if I put that G back there or whatever, another letter, refresh it, we should get a false now. And we do, we get a false, okay? And then if I remove that and leave that F there, it's still going to be false. But if I remove that, now it is exactly the pattern we're expecting. Perfect. Okay, next up, the user has passed the test. They put in the proper data. Now let's say that we want to store that data in a database. Well, when we store it, we don't want to store the parenthesis and the hyphen. We just want to strip all that out. And so we can do that by using those little $sign variables we talked about a minute ago. Okay, so let's go back to that tool here and see. So if we open up the substitution link down here and we look down here, right now, none of these are grouped, right? So I'm going to go ahead and update this regular expression to have our caret that we didn't have in it before and the $sign that we didn't have. All right, so now it matches our code. But now what I want to do is group the 999 that's inside the parentheses and then the 999 after the parentheses and then the 999 after the dash. So I want each of those in a group, right? So the reason I want them in groups is because I only want to store that piece. Let's look over here in the text editor. I only want to store this first 999 there, butt it up against that, butt it up against that. So in other words, what I want to go in the database is that, right? So how can we do this? Well, if I group the 3 digits here by putting them inside of parentheses, and now at this point, the parentheses, we're talking about a group, not the parenthesis that is the character we're looking for in the pattern that the user put in, right? We're talking about the parenthesis as a regular expression functionality that groups things together. And then we're going to do it again around those three, the 3 digits there. And you see how it turned orange down here, and it's going to turn another color here, like so. So now you can see that the whole pattern is still matched. You can see the light blue in the background of that top number, but then the first 3 nines are a grayish greenish color, meaning that's one of the groups. Then the next 3 nines is a orange color, and then the last 4 nines is a purple color, letting you know those are the 3 different groups. Okay, what we're going to do next now is, remember the first group there, those green ones, is $1. So if I were to say $1, then you'll see that it just displays those first digits there, right? And let's change this to something that's a little bit more easy to distinguish here. So we're going to go 801, and we'll go 913, and we'll do 2468, right? So you can clearly see that 801 is $1 variable. And so if I wanted to just print 801, that's what I would put, $1. If I put $2, it prints 913 and so forth. So if I just did 1, $2, $3, that gives me the whole phone number without all the extra stuff. So how do you do that in our JavaScript? All we're going to do is take the user input and use the replace function on it. Now, if I wanted to right now, let's just ignore the regular expression and just take this phone number, and if I say replace 9 with 8, what this will do is replace the first occurrence of 9 with an 8, which is a silly thing to do, but just I want to demonstrate that this function replace doesn't have to use regular expression. And of course, if we want to see it, we should probably print it out. So let's console that out right there and try that again. And you can see that first 9 is now an 8. Okay, but we don't want to do that. What we want to do is replace this whole thing with just 99999, right? So what we want, let's turn this back on so we can just see it. We want this whole thing right here. That's what we're searching for, right? The first parameter is what you're searching for. And again, notice this regular expression is not in quotes. It's just in those forward slashes. But we also have to add the parentheses so we can get access to those groups, right? So the parentheses went around the D3 and then around, oops, I put that one in the wrong spot there. Right there. And then around this D3 and then around this D4. So now we have the three groups just like we did on the Regex 101 page a second ago. But now I have access to them. So right now I can replace, oops, let's put that in quotes there. I can replace this whole thing in this string, right, which is this big thing here. So I can take this string right here and replace any occurrence of that with that. Now that's just going to give us plain old 999, right? So if I refresh it, and that just gives us 999. But if we do like we did in the Regex 101, I can put 2 and 3 there, and now that will replace it with the entire number, but all the other stuff inside of it stripped out. And again, let's put a real looking number here. 456 7890. And so you'll see it just replaces the phone number input, stripping out all of the extra stuff that doesn't matter and displaying just the number itself. Now, obviously, we weren't going to display it, right? We were going to insert that into a database or whatever. So the way this code might go, you'd have a web form where the user put this number in. Then you would have this pattern in your code. In fact, let's just change it to this pattern right here so that they match. So you have this pattern in your code. And then the next group of code would be checking to see if the pattern matches. So it would be something like if this pattern matches, then we would do this next thing here, which would be inserting it into a database or whatever. So this is going to be, you know, faux DB insert, right? So you would have real code that inserted it. But what you would do is they'd have to get past this piece of it first. If this wasn't valid, you would make them re-enter the data. But once they get the data right, then you come down here and go, okay, now that you did the proper format, so I know it's a valid phone number, now I'm going to strip out the extra pieces and replace it in the database so that it only looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Now you could argue that making them put a parenthesis around it, instead of, why not just make them put the 10 digits in a row? Why not just make them type 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 or whatever their number is? Well, because it can be a little bit tricky when they're typing in a field, you know, some of their phone numbers 801 238 8447. That can get a little tricky to make sure you didn't goof up when you're typing if you don't force them to use some sort of pattern. So that's why we do that. So there you have it. That's regular expression. That's a fun tool online, Regex 101, for how to use regular expression in practice. And I will use that tool. I'll go into there, put the thing I'm trying to capture or test in Regex 101. Then I'll build my regular expression and test it in there. And then I'll put it in my code and test it there. But it's a lot easier to test it in that tool where you can just test it real time and not have to worry about rerunning and refreshing your page and all this stuff. But once I get the pattern, dump it in the code, then test the code live, and you're all set. Well, that's it. Now you know not everything there is to know about regular expression, but a whole bunch more, hopefully. So thanks for coming to class today. As always, if you can answer the questions on the screen there, then you're ready to take the quiz and you learn what you needed to learn from this video. We'll see you next time, folks.